there is no min or max.
Okay.
So it has to be a closed interval.
Okay.
So let's go to number 2 whenever you're ready.
Yeah, I'm ready.
Right, 2. All right, so number 2. So when the derivative is 0, that means that there's a horizontal tangent,
Okay.
and that could either be a max, a min, or neither. Okay, so when you look at the graphs here at A and B, let me snip these in. Sorry, A, B, C, and D. Snip them in horizontally here so we can see all 4 of them side by side. What you're looking for is do any of the graphs have horizontal tangents at A and B? So like that's a horizontal tangent and that's a horizontal tangent. It's not really well, B is kind of hard to see, but it comes down and then it comes up. Oops, and it's a straight line down, and then it's kind of like a corner there.
Okay.
So that one's out.
Okay.
These also have horizontal tangents. D is straight line up and then kind of like a corner again, so it's out. So we're down to A and C, and it's like, okay, well, what's the difference? Well, the difference is that at C, you want to think of this as a slope of -9, which means it's going down and to the right.
Okay.
Okay, so which of these graphs goes down and to the right at C?
A.
Yeah, and sometimes you got to draw that tangent line just to see it.
Okay. Okay.
All right. Any questions on that?
No.
Okay. All right, sketch the graph of the following function and determine whether the function has any absolute extreme values on its domain. Okay, so first thing is that this is an open interval because the less than and the less than here, they correspond to the parentheses. The less than or equal to's, and less than or equal to, that's the brackets. So these are the bubbles and these are the filled in ones. And what that does is it tells you there's actually 2 graphs that it can't be. It can't be B and it can't be D because of the filled in circles there, because it's an open interval. So it's either A or C. You remember how to tell? Do you remember how this transforms the graph that's x minus 1 inside parentheses?
From what I remember, I think it inside.
So this moves it right 1. And I
Okay.
guess if you
I was
needed to,
gonna
you could
say
graph
down.
that.
The
Yeah,
cutoff.
so down is outside. You could always
Yeah.
graph it to figure that out, but that is the correct graph there.
Okay.
So I mean, you have your calculator. You can always graph it if you're unsure. That would help, but that won't help with the like open and closed part
Yeah.
of the interval.
Mhm.
Okay. All right, determine whether the function has any absolute extreme values on its domain. So does it, what it's really asking is, does it have a min? Does it have a max? Okay. What do you say when you see this graph? Does it have a min? Does it have a max?
Well, because of the open holes, does it mean they don't have it, or that just means it's not continuous?
So if it's an open hole, there's nothing there. Like even though, like imagine getting to, let's like, I don't know, it's a terrible analogy, but you get to the top of a mountain and there's nothing there. Like you
Okay.
fall in or something. Like there is no peak. There's nothing's there.
Okay.
Which it's not a great analogy, but it's like there is nothing there. So there
Yeah.
can't be a max if there's nothing there.
Okay. So I don't think there's an absolute max.
There's no
Would
absolute max.
yeah.
What about down here?
Could you say the minimum is 0?
Yes, but so in this case, it's just saying where the minimum is.
Okay.
So the minimum is when x equals 1. There's a min.
Okay. So it would be C.
Correct. Okay. Fantastic. So um again, this is the function is continuous, is not, is not. It is continuous on an open interval. Like the
Okay.
open interval means the endpoint. So it is continuous in the open interval. That means that B and B are out. Okay.
Okay.
Well, actually, it's just A because the A is the open interval. Since F is continuous in open interval, it may or may not have any absolute extreme values on its domain. And that's kind of what we saw. It has some, but not all.
Okay.
Any questions on that?
No.
Okay. All right. So the best way to do number 4, is that what we're up to? Was that 3?
1, 4.
4. Is this is 4, right? Yeah,
Yeah.
this is 4. So the best way to do 4 is to graph it.
Okay.
I know that you don't have that's most available to you, but like it really does make a big difference if you can graph these things. And what I will show you here is 3 less than or equal to x less than or equal to 4. Ooh, that's not what I wanted. Is if you restrict the domain, and I'm gonna snip this in so you can see how to do this. The graph really tells you everything. Like this course should be done with a graphing tool like this. So it shows you, like if you see how it's in curly braces here, you put the restrictions -3 to 4. Okay. So you generally like label the endpoints, you label any sort of critical points in between 0,9 and 4, 4,-7. So something like that. So now we can answer all the questions. So I don't know if you have that. It's gonna be a little hard for me to show the graph. I can scroll back and forth, but it's asking you a series of questions here. It says, okay,
Yeah.
does it have absolute max? And it asks you 2 things, and this is where I think it's maybe a little bit unclear. It's asking where is it, and then what is it? Okay, so the where is always the x value. The what is it is the y value. So the
Okay.
absolute max, where is it, is at 0, x equals 0. X equals 0. What is it? What is it? And I don't know why they do it in this order. I think where comes before what, but that's not the way they do it. It's at 9.
Okay.
All right, find the absolute minimum value. So the minimum value, and you go back to the graph, okay? Where is it for, what is it, -7?
Okay.
All right, and then the graph. And we already had the graph, so it looks like that one there.
Yeah.
There's not really a way to do this on the PI. You can kind
Yeah.
of do it with the window where you just frame the window from -3 to 4, but it's not great,
Yeah.
but it could be done. What you typically want to do is like find the two endpoints, and we will do this in later problems, and then find any mins or maxes.
Okay.
All right. So 5, kind of the same thing here. The way I'm showing it to you is with a graph. I'm not showing you how to do it by hand. I don't think you need to know how to do it by hand, especially if you're allowed to use a calculator.
Yeah.
So this one is from -1 to 8, up to the 5/3, like that. All right. So yeah, there's always that issue of like getting the window scaled properly and all that, but yeah, just snip all this in case you want to look at it later. So yeah, again, you just graph it here. The lower endpoint here is -1, -1. And then this one over here is 8, 32. And so if
Okay.
you were to do this by hand, I don't know if you can see that there actually is a horizontal tangent right there. Because the graph kind of comes up and then does like that, which is hard to see, but it is if you zoom in there. But that's good. So the answers make this the most challenging. You have to decide, is there an absolute max? Is there an absolute min?
Mm-hmm.
And there's the min is over here, and the max is up here. And
Mm-hmm.
it's a closed interval, so you have one there. Open intervals possible, not sure sometimes. So let's see here. The absolute maximum is 32 when x equals 8.
Okay.
So again, it's that whole, where is it? What is it? When they're the same, that's easy. You don't have to think that hard about it.
Okay. How would you know if there's a hole or not, though? Oh, because of the equal
Yeah,
sign.
the less or equal to.
Okay.
We can go to
Yeah.
question
Yeah.
6.
Cool.
All right, question 6 here. All right, give me just a moment, please.
Okay.
All right, so this type of problem here, I'm back here. This type of problem, you can do by hand by taking the derivative and setting the derivative equal to 0,
Okay.
or you can graph it. So you can probably, tell that like my preference is always to graph stuff like this.
Uh-huh.
This one is different though. It's an entire interval. Or I'm sorry, it's everything. So there's not like a there's how do I say this? You have there's no restrictions. You have to graph the whole thing. And I think they choose a problem like this because it's easy to not see part of the graph, especially if you don't zoom out. So you might
Mhm,
think, oh, it's just got a max, or oh, it's just got a min, if you
mhm.
don't graph the whole thing. Okay. So critical points though, critical points are where the derivative equals 0. So it's any sort of horizontal tangent. So it could, like I said, it could be a min, could be a max, could be something like that, could be something like that. Okay.
Okay.
So here it's the x values, 0, 10, x equals 0, x equals 10.
Okay.
So you might think like all the problems can be done with the by graphing. Then right when you think that, we get problems where you can't do it with graphing. So
Yeah.
this is the mean value theorem is next, like this. Okay. So the mean value theorem says f of b minus f of a over b minus a.
Okay.
All right. So to do this, we have to actually figure out what's a and b. That's a and b.
Okay.
F of 2 and f of -1. So I'm going to ask you to get involved.
Mm-hmm. Do I take the derivative first or no?
No derivative yet. So it's 5 times 2 squared plus 2 times 2 minus 3. 5 times -1 squared plus 2 times -1 minus 3.
Okay. The first one I got 22.
Okay.
Mhm. Then I got -2.
Here, 2 like that. Okay. So that's the numerator. That's 22 minus a -2 over 2 minus a -1.
Okay.
So what does that become?
24 over 3. And then that's 6. No, 8. I'm sorry. Not 7.
That's 8. Good. So that's the left side. Okay. And now you're, like you said, you need the derivative. So let's determine the derivative. That's why you learned all that derivative stuff.
Mhm. Okay. 10x plus 2.
10x plus 2. So you set those equal. You set 8 equal to 10x plus 2. And then you solve for x on this. And actually, this one doesn't work out super nice, but oh, it does say fraction in the answer. So I guess that's expected.
Yeah, it'd be 3 over 5.
3 over 5. Yeah. There you go. There's your answer. So that is the answer to a c equals 3 over 5, or just the 3 over 5 is what goes in there.
Okay.
All right, so number eight here. All right, so for, again, kind of the same thing here, A and B. So f of B
Mm-hmm.
minus f of A over B minus A. F of 20 means 3 times 20 plus 3 over 20. And then f of 1 over 20 is 3 times 1 over 20 plus 3 over 1 over 20. So let me know when you come up with those values. You'll
Um,
find, you'll find they're actually very similar.
yeah. I think I got the same thing. I may be wrong.
They are the same. What's the numerical value?
I got 1,203 over 20. I don't know if I put it in the
I would,
calculator.
why don't you calculate again? 3 times 20 plus 3 divided by 20. I mean, it's a
Yeah.
number. It's not, it's not.
Um, 60.15.
Yeah. Minus 60.15 over 20 minus 1 over 20. So, if you're coming with your calculator, you just put this in the calculator. But like when the numerator is 0, that's a big deal. When the numerator is equal to 0, 0 over anything is 0.
Okay.
So the whole thing is 0. Okay, so the left side here is 0. All right, now the left side, we have to take the derivative, or sorry, we have to take the derivative. So what's the derivative of f of x? F of x equals 3x plus 3 over x, or you can write it as 3x plus 3x to the minus 1. What is the derivative of that?
3 plus or 3 minus 3x to the negative 2.
Yep, or 3 over x squared, and then you'd set this equal to 0.
Okay.
All right, so what does this become?
Minus 3. Negative 3.
So to solve this, yeah, maybe I'm being fair here. I mean, to solve this, you would move the 3 over x squared to the other side.
Mm-hmm.
So you get 3 equals 3 over x squared. A lot of ways you could do it by here. A lot of students just diagonally multiply. So
Mm-hmm.
3x squared equals 3, divide by 3, x squared equals 1. So x equals
1, right?
plus or minus 1.
Yeah. So it would be -1 and 1.
Yes. Now, the question though is, are these numbers in the interval?
Mm-hmm.
Are they both in the
Okay.
interval? And only one of them is.
That's one, positive one. Okay. Okay.
Right, so that takes care of that.
Mhm.
Okay. Next question here, number 9. So there's like all these rules for the mean value theorem, okay?
Okay.
So like is it continuous? Is it differentiable? And these all come from the definitions of that. So let me pull this up here. And I go to this reference for calculus. This guy's got some great online notes. So here are the requirements. These are the ones to kind of get down in your note sheet. Does the function satisfy any value theorem? So is it continuous? Is it continuous on this interval? So for me, the best way to see if something is continuous is to graph it. Okay. And I don't know if you like that. I don't know how else you're supposed to decide that. But is it continuous on the interval from -2 like that? So let me snip this in. It looks like a V. Okay. Just like that. So is it continuous? Is it continuous? Yes. All right.
Okay.
Now the continuous just means can you draw it without lifting up your pencil or passes the vertical line test.
Yes.
All right, so that's okay. Now differentiable is different. Differentiable means that it always has the same slope left, same slope right. So when the places where there's issues are corners, cusps, or any those are the two possibilities. Or I guess, yeah, corners or cusps.
Okay.
So is this differentiable everywhere?
No, because of the
That right there.
yeah.
So that's how you answer this question. You have to sort of know this right here. So function is continuous everywhere. That's true, but it's not differentiable. So yes, it's continuous everywhere, but it's not differentiable. So which of these says that? It's continuous everywhere, but not differentiable.
Ooh. It's D. Wait.
Yes.
Yeah.
A little bit awkward. I mean, that's why I'm having you do it because it's you got to be able to do this. Okay, so wow, or you're moving into the other part of the course already. Interesting. Okay. So 10 starts the next part of the course.
Okay.
All right. Find all possible functions with the given derivative. Okay.
Mhm.
So this is going backwards. It's like, well, what function gets you back to x to the? So the rule is for x to the n. You add 1 to the exponent and divide by the new exponent.
Okay.
Okay, so to go backwards now, which is you're moving into a new part of the course, which is called the integral or the antiderivative.
Okay.
or the integration, things like this. So you add 1 to the exponent and you divide by the new exponent. So do you agree that this derivative, or this function's derivative, is x to the 8th? Like if you go, like, and this is where it gets hard because you have to remember, well, how do I take a derivative? Well, you bring the 9 down, the 9 cancels with this 9, then you
Mhm.
subtract the exponent. 9 minus 1 is 8.
8.
Okay, so it's this. Now, the thing that's new here is that you have to add c. Now, you said you've taken this course before, so maybe you remember that.
Yeah, I remember talking about it, yes.
So the idea is the reason you have to add c is because the derivative of a constant is 0. So we don't know what the value of c is. We don't know whether it's 0 or 1 or 50 or pi or anything. You just know that you're adding something to it.
Okay.
Any questions on that?
No.
All right. So like normally we would do a lot of practice, a lot of like getting used to this idea. 11, is another type of problem that there's rules. There's all these rules for antiderivatives, just like there's all the derivative rules. So it's that reference sheet I sent you for derivatives. If you go to page 2, there's all the ones for integrals, and I can resend that if you need. So
Yeah.
the integral of a constant, actually I shouldn't do it that way. Sorry, I'm trying to undo. The integral of a constant dx is constant times x plus c. So this -4 is the k. Like the antiderivative of constant is -4, and then you put an x with it.
Okay.
This is where it gets confusing. It's like, wait, well, there was no x. Yeah, you're right. There is no x. But the derivative,
Yeah.
derivative is -4. Now there's this rewrite step. Okay, so just like before, the integral of x to the n dx, you add 1 to the exponent and divide by the new exponent. Okay, so we're going to add 1 to the exponent, and then we're going to divide by the new exponent. And it's okay at first to show it this way so that you get comfortable with it. So it's -4x plus x to the -1 over -1. And then you can bring this -1 in front. So it becomes -4x minus, and then x to the -1 is really 1 over x. So you can write 1 over x, but you cannot forget that plus c. And it's usually uppercase. I should have said that in the previous problem.
Yeah.
I don't know how your system takes it. I don't remember.
Yeah, it's uppercase.
Okay. Okay. Let me know if we can move on to number 12.
Yeah, we can.
So number 12 is like the ones we've been doing, but now we're going to be able to find that c value after we take the antiderivative. So the rewrite here, it's always good to do the rewrite, is it's 4x to the -5 plus 12x cubed. Okay. All right. So you're going to add 1 to each exponent. Okay. So it's 4x minus 5 plus 1. And then you divide by the new exponent. Plus 12x 3 plus 1, divide by the new exponent 3 plus 1.
Okay.
So this is the new function here. And so this is what you're gonna have to want to practice is these antiderivatives. Get really good at those. So it's
Okay.
4x to the -4 over -4 plus 12x to the 4th over 4 plus c. Should have been a plus c there. And then you do want to simplify here. So it's negative 1 over x to the 4th. The reason the negative comes from this, the x to the -4 becomes 1 over x to the 4th plus 3x to the 4th plus c. And now we can use the fact that there is this point, this initial value. Okay. So
Okay.
this is your x and this is your y. Okay. So you put 1 in for x and then g of x, y is really g of x in this case. I don't know why they're using p. They shouldn't have used that notation. I guess they just said point p, but so it's 7 equals -1 over 1 to the 4th plus 3 times 1 to the 4th plus b. So this becomes -1 plus 3 plus c. So that's 7 equals 2 plus c, c equals 5.
Okay.
So the final answer, this is where, you got to, it's kind of like when you learn how to write the equation of line is you go back to this line right here
Mhm.
and you put in the value of c is 5. And then this is what they want here on the right.
Okay.
Any chance we could just stop a little early today?
Yeah, that's fine.
Kind of got through everything here.
Yeah.
So probably need another lesson to get through everything, but
Yeah.
I'll make sure we do.
Mhm.
So, all right. Well, thank you so much for scheduling. I will see you